So in this video, I'd like to take our discussion of addition and multiplication and turn it into a general definition that will be the guiding principle through all of the theory that we do in the next part of the series. And so this definition is the definition of something that mathematicians call a group. And addition on the real numbers defines a group. And multiplication on the real numbers without zero defines a group. So if I say R and plus here, and then I want to say R set difference 0 and times. So a group is first a set G, we use the letter G for group, with a operation, and this operation, this is not a technical term, so maybe I'll erase this. This isn't something you should remember, but it's just a set with a function that is from G cross G to G, and maybe I'll call this operation star because I don't know if it's plus or times, and so of course my notation, so I want this to work like plus and times. So when I write A star B, what that means is I'm taking the function star and evaluating it at A and B. Remember, when I just have a function, the notation for evaluating that function is this stuff with parentheses right here, just like I would write f of x, right? But what I really want is this to be like addition or multiplication. I really want to write it like this, and so that is what I'm going to do. But this function has to have some special properties. So I have a such that, and I have three things. First, associativity holds. And associativity means that for all A, B, and C in G, I have A star B star C is equal to A star B star C, meaning whatever order I do my addition and or multiplication, well, I don't think I could have addition and multiplication, but addition or multiplication, whatever order I do it in, it's the same, which justifies the notation A star B star C without the parentheses there. If I didn't have associativity, I'd have to keep those parentheses there because they could be different things. And the second thing that must be true is I must have identity. An identity is this property where I have a special element. So before, the special element for plus was 0 and for times it was 1. But here I'm just going to call it E. So there exists, that's what this backwards E thing means. It means there exists an E in G such that ST is my abbreviation for such that for all A and G, so for anything in our group G, I have this A star E equals E star A equals A, meaning this is when I multiply by the E, which I'm going to call the identity element. When I multiply E times A, I always get A. When I multiply by E, it never changes anything. And you'll notice I wrote these two different forms of multiplication, whereas with addition and multiplication, I only wrote that 0. I wrote 0 plus a equals a. I didn't feel the need to write a plus 0 equals a because you already knew that 0 plus a equals a. Well, for groups, I'm not going to assume that they're commutative, at least not just yet. So I need to write both of these things down. I really do need to write a plus e, or a plus, or I should say star, a star e, and e star a is equal to a. And that's why both of these things are there. And now the final property, and the most important property for a group at least, is the inverses property. And that inverses property says that for every element, I'm calling my element A, there exists another element in G, which has the property that A star B equals the identity. For addition, I put minus A for B. For multiplication, I put 1 over A. Because I'm not assuming that things are commutative, I better put B star A here as well. And once I have this definition of inverses, I don't want to really, this B here is not a separate thing from A. It's sort of tied to A in some way. So what the notation I'm gonna use, notation is kind of standard for mathematicians, is to use A minus is this B. And so this A minus 1, A to the minus 1. And you read A to the minus 1 as A inverse. So A inverse times A equals E. So if I were to write that, it would be A inverse times A equals A times A inverse equals E. And we use this little minus 1 thing because it's sort of suggestive in a way. If you're thinking about multiplication notation, A to the minus 1 is the same thing as 1 over A. But this to the minus 1 thing there, it doesn't imply that you have some sort of division like 1 over A is. So you can think of it, A inverse being the same thing as just minus A if you're talking about addition. So that's it. That is the definition of group.